Hello and welcome to Migration Risk to Avoid for Dassault Systèmes 3DExperience. This is the third part in a four-part migration webinar series about 3DX migration. This one focusing on specific migration risks and solutions that you can use in order to kind of mitigate those risks and different strategies as well. My name is Brian Scouten. I'm Director of Technical Presales for ProStep Inc. And with that, we'll get into migration risks to avoid. So we've identified risks really throughout the whole process of migration. And we're going to dig into each of those individually. That starts with the specification. That could be the scope and the requirements, technical processes that go along with that and identifying those. Risks that might be associated to exporting data from these source systems that you might be leveraging for the migration. Risk to mapping, risk to translation and transformation. Some of that might involve CAD data or generalized visualization translation. Risk to import, so best practices for handling those. Performance as an overall issue within migration and drivers for what those performance issues are. And then, processes that you can use in order to improve performance, as well as techniques in order to make your migration work better. And then general user acceptance, and migration being a component of new system introduction, especially just for maybe user group. It could be an existing system, but how to make the migration a success and make your implementation of a whole PLM a success in the end. So let's start by talking about specification challenges to the migration. This is really requirements driven, and so requirements on the scope of the data that you need to take, requirements on the overall performance of the migration. So, what the window of opportunity is in order to execute the production migration, if that's like over a weekend or over a week or, even maybe less than that. And then, from there, then you can define what the processes that are needed in order to support that would be. You might be able to do an ETL in just one phase if you have a small set of data. You might need an initial load and then a delta update. So doing that a little bit over time in order to meet that performance window if you've got more data. And then also, if you have just a huge amount of data, maybe that coexistence style approach is more attractive for it. You need to also take into account, the user data that's within the source system. So think about the changes and the approvals to those, the history of the different tasks that users have, workflows. Things like that are not going to align between the old system and the new one. So you're going to have to come up with alternative ways in order to present that. In some cases, we would take a change history PDF, capture all that approval data, or something similar to that in order to be able to migrate that, because the new system just doesn't have the same processes. And then also data cleanup and evaluation of data early on is going to then enable you to make changes to clean up the data for migration. So that means that, if we get in and run through some of the processes early, understanding, what might have worked within the old system might not be working in the new one, just because, that's a limitation of new system functionality or something like that. Make sure that you've got the test data you need, that you've got the test systems like the old systems, the migration hardware, migration licenses, users, and other SMEs available for this. And then with all that together, sit down, specify, define the processes that you're going to need for migration, and then start there. So with the specification completed, typically the first defined sprint is the export. And this is also generally the easiest component of migration. So The best performance that you're going to get on export is really going direct from the database. So that might mean you need to reverse engineer the schema of the database in order to pull data from there. We also at ProStep use the certified APIs of these systems in order to pull data in many cases. Sometimes there's a high performance API that's specifically used for migration that we can use as well. So those exist, and depending on the performance requirements, we could adopt those. Make sure that the data aligns, so that the SMEs are available so that you can do the alignment of the data, understand where the mapping requirements are and where the cleanup might needs to be. You need to, at export, also consider the conflicts that might exist between multiple systems that you're exporting data from, or between the old system and the new system. And then also at export, be able to generate reports from the source systems on the entirety of those different edge conditions that you might need to do the cleanup on, and then go ahead and get that taken care of. Now, those source system APIs or direct to database is the best performing way in order to get that data. But in the case of CAD, sometimes you need to actually use the CAD application interface in order to get the data out. That might be for a couple different reasons. So it could be that on the export, there's some introspection done within the CAD. That then enables you to the system to dynamically kind of go and get more data from the source and then pull all those documents and binary files that might be dependencies together. There could be a rename that happens as part of the export process. And so when that's renamed not just in the source, the one file, but it might also be renamed throughout the references to that file too. So there are operations like that then require you to use specific CAD APIs. You can also do scans of CAD, external to the system, but you need to understand what the needs are as well for importing the data for CAD, and make sure that those are taken into account. So let's move on to mapping and translation risks and solutions to those. So key to mapping, starting there, is the primary key alignment. So identifying uniqueness of all the data within the source system and how that's going to uniquely then be provided to the target system, especially if you've got multiple sources of data that you need to align. Identify what those keys are, make sure that's known, and then you can merge data. You can understand data conflicts between the different systems as well. Make sure you've got that process like we discussed before about handling data that's not easily mapped. So, if there is the data you need to carry over, like those change, sign-off history or things like that, we can create those reports from the data that's within the source database as part of the migration process, and then process that there, right? If you're merging data, make sure that you understand data conflicts between the different sources as well as the target. In dealing with the conflicts, generally you could either determine what is the right set of data to use, and that's the pick of winner philosophy, or re-identify that data maybe later. So as part of the import, create another ID that then represents that, right? And then you can then change that later on once you've gone through manually and figured out what that data is and what the right place for it is. You need to consider downstream integrations and mapping too. So sometimes source data doesn't have all the required fields for, let's say, that ERP integration that your system is using. Make sure that you've defined like what those requirements are in order to make that functional, and actually include that in the mapping to populate those mandatory fields. On the CAD side, there's also risks in handling that in CAD translation and upsave. So The first thing that you should consider is when to do the translation. So you could do the translation before the migration, you could do it during the migration, or you could do it after the migration. If you do it before the migration, generally it's out of scope of the migration, right? If you do it during, there's performance implications to doing that. There's also implications to the quality and analysis of that data that you're going to have. And you might not be able to go back easily. You've got to dig that data up and then reprocess it, right? If you do it after, you're effectively not translating the data. So there's going to be more data work that needs to be done after the migration. But you'll have both the source and the target of the translation within the new system. So there is some advantage to that in doing the data after the migration, although it is more complicated in general. CAD data upsave is also generally a thing that's pretty popular within migration. So CAD integrations don't always support all those legacy CAD files that you have. So you have to have a mechanism in order to load it into a preferred format that you can then use. And that might be, upsaving your SolidWorks data, upsaving your Creo data, something like that to a later format that's then supported within the application. The migration also might need to be able to process CAD data and understand all the dependencies behind it, especially if you're coming from a directory that has different CAD files on it, and that's your source data. You have to do a scan of that data, but then you need to also look in the binaries of those CADs and understand all the dependencies, like the files and the attributes that are in those as well, so that you can, build that data web of dependencies to be imported into the PLM. We have a high-speed tool that we use for that, but we can also use slower CAD API tools. And depending on what the needs are, you could use either. They use seats of CAD with the slow API, so you have to load the data and then be able to process it and then get the results and things like that. You have to understand the limitations of the CAD integration with the systems and how it handles and interacts with the data, how it saves the data, and it might not have the same feature set and format support. So just make sure that you've compared the requirements of the old one and the new one. Lightweight visualization and generating that data is important process as well. That can be done during the migration at check-in. That could also be done as a post process. So you've got the queue that's developed of all the CAD that's been checked in, and then you need to generate the images and the viewables after you've done the import. Make sure you are understanding what the performance needs are, especially with CAD data. Dealing with CAD is generally pretty slow, and so it's computationally expensive. And so it slows down the migration process in general. And there's ways that you can speed that up by parallelizing it, by doing things before or after, but factor that whole strategy in together. And it also might require some CAD licenses or user seats or third-party licenses, depending on what you want to accomplish. Let's talk about import processes and risks and challenges and potential solutions for migration to 3DX. Number one, use the right APIs for the right types of data. Data can sometimes be grouped together and then processed together through a specific API. So you might use more than one, actually in most cases, you're going to use more than one API as part of a migration. And so you can tie together different APIs for different functionality and other performance reasons. You can also group data together into kind of a packages that best suit the performance of that API and kind of match what the system performance would allow it to have. Yeah. So really there's three standard APIs that we typically use for import into 3DX. Number one is MQL or MQL over RMI. You can use the RMI interface for this. And this is the legacy matrix query language API that supports a lot of the legacy data models within 3DX, but more modern data models within 3DX, CAD data integrations, things like that are not supported through this. So you have to kind of pick and choose what you can do here. But you can also embed JPOs and execute those as part of MQL, do things like that. XPDM, and this is the integration point that we use for most modern CAD integrations. So that works with the Power BI interface. So that is the using legacy CAD or third-party CAD integrations into 3DX, and then also can use CATIA integration or third-party or native client tools for batch import processes. So if you want to import STEP or do an upsave in CATIA, something like that. The third interface and the most modern interface is the RESTful interface. So this is one that is also workable with the cloud. And we haven't really talked about that much about 3DX Cloud versus on-prem. Most of these processes are centered around an on-prem deployment. But if you're looking at a public cloud implementation, you can use the RESTful interface and import data through there. Dassault also has a tool that they can use in order to move some CAD data from a local instance in 3D XML formats to the cloud as well. So we can kind of incorporate those together in order to try and provide good solutions. And then other custom system import tools, right, that we can develop and deploy within the system in order to provide some functionality there. On the CAD import, special considerations, and CAD is a major focus as it's a big performance driver for most migrations in general, but specifically for 3DX is the case. You got to be able to open the CAD in order for it to be processed. So if you are in an environment that has some dirty CAD, you got to clean that up so it can be opened. When you're working with CATIA or SolidWorks or a CAD system that DS provides, then they have a mechanism for generating CGR data as part of the import process. So when you go through and use XPDM interface in order to push the data in, it'll generate the visualization for that. So if you're doing that for a non-CAD or non-DS CAD, like you've got Creo or NX or Inventor data or something like that, you need to actually generate the CGRs and then provide that as a requirement of the interface in order to use that powered by integration. So generally we use the translation services that Dassault provides and that module in order to generate those CGRs as part of the workflow. There's a lot of data requirements that you need to be able to resolve and provide to the XPDM interface when you're doing this through the import. So all those relationships, like the multi-models of the drawing links and the family tables and other types of internal relationships, you have to evaluate the CAD data, scan that, make sure that you have all those known that are dependencies of this CAD data, and be able to provide that through XPDM so that at the import time, it knows exactly what to create. And it does have some limitations, right, for historical data and what processes can be done. Generally, we use parallelization in order to make that import faster. So that might mean that you also need to improve the performance of the 3DX server as well in order to handle larger loads of data on that initial load. And just a special note about the unified product structure, UPS. When you're dealing with the UPS, sometimes you really need to work on merging data that might be available or having different representations of data created within 3DX. So many source systems, might have a design and an engineering bomb, like it's a native concept in Windchill and in other systems. But in the UPS model, those things kind of need to fit together, or you need to specify configurations in order to make sure that that data aligns well, so that it's similar in when you're pushing that data downstream. And that might mean some data cleanup and data alignment, but it might have more value that you do that cleanup instead of starting with a split design structure like a legacy Innovia structure. And generally, we see a lot of challenges, within those environments that have started there and now need to do an internal migration. That's another headache that you're kind of adding to the migration pile for 3DX. And in general, performance is a major consideration when doing data migration. And we're talking about the ability to quickly export, map, transform, and import data. Generally, the faster the migration, the better. And that needs to be defined early with the requirements, what the expectation is. But that's going to drive things during the migration that takes time and expense. So especially if you're doing an ETL style migration and we're running multiple full data rehearsals, if it takes 2 weeks to process all that data through an initial load and a Delta update, well, it might take 3 or 4 weeks to do a complete rehearsal. And if you're doing 2 or 3 of those, that's a lot of time in order to process all the data for testing. And that needs to be accounted for. Yeah. Generally, data is fast, right? So creating items, item revisions, parts, BOMs, changes, those types of data, that's pretty quick. Data set upload, like for files, that's also fairly quick, but the streaming of the binary files is sometimes a little less performant than just creating the data. And then CAD is slow, and not all CAD is created equal. Some is worse than others, but that's a major factor in driving in the overall performance of the migration itself. We want to make sure that we're using the right API for the job, and that mostly comes into organizations sometimes skipping CAD APIs in order to try and get the data in through a different API. But then finding that they're having data failures in the future or things aren't working as expected. So using the right API is going to guarantee your success and make sure that you've got usable data. Depending on what the requirements are for downtime, make sure you've got maybe an initial import and a Delta update or even a coexistence type of model. We want to be able to meet those requirements, so we need to think about how we're going to approach it early and then define those processes to make sure your migration is good. We can handle performance by parallelizing. So that means that we could have multiple servers and multiple processes per server that then all work together in order to provide kind of a maximum throughput. And our OpenPDM Migrate is built in order to do that for high performance. That also means that you have to tune the systems so they don't crash as part of the import processes. So you've got adequate heap space and good garbage collection and things like that as part of these import processes within the systems itself, not just the migration. Yeah. We batch data, so we try and collect data into like types, but then also maximize the volume or optimize the volume of data that can be pushed through each of these transactions. So if we find that 1,000 parts is an optimal amount of parts to be created all at once, then we can try and do that. Or if it's 500, or if it's 10,000, or if it's 20, that batching can limit what the transaction time is overall. And don't sacrifice quality, right? So in the end, data migration is a big component of user acceptance, and the quality of that migration is super important. So if you're trying to do something during data migration that isn't optimal and might affect quality, think about that and try and go the right path. And with that, and really the final component to risks and PLM migration is the system acceptance. So this is probably the most important part of it. Migration is a big component of system acceptance, making sure that the data is correct, making sure that the users are happy within the system. So as part of migration, you want to make sure that there's a lot of training that's going on. You want to make sure that people understand the benefits of the system, what it's going to help with the organization, how it's going to help them do their jobs easier and better, and how their old data looks, right? How to do the same types of processes that they were going to do, and make sure that they can support those processes within the new system. Sometimes that's done through like a train-the-trainer system of community experts, and that's great. But we also want to make sure that we divide the people who are doing migration testing and kind of insulate that from the training and the trainers themselves. And that's because when you're doing migration testing, you're going to deal with all the challenges and the issues that might go into the migration. And see broken data within the system, and generally maybe have not a great attitude towards the system because of that. So make sure that it's known that the ones that are doing the migration testing might not be the best spokesman for the system overall, just because they've dealt with, I guess, making of the sausage, in effect. And make sure you plan to communicate, and make sure you're planning to discuss, what the benefits of these systems are, and, how you're mapping the data, and, the processes you're using, and try and win over people. And that's going to be super important to the success of not just the migration, but the new PLM. And in general, even if we meet all the requirements of the migration, if the user community isn't happy, it's not seen as successful. That's something that we always strive to do, is to make sure that everyone has a good result from the migration, including the downstream users. And remember that ProStep is here to help. We specialize in cross-vendor migration and integration. We've been doing this for over 30 years. We've got over 100 consultants that can help on these projects all over the world. So reach out. We definitely have the right tool sets and software off the shelf, as well as expertise and best practices in order to guide you through these types of migrations. And this is typically a one-time event, so it's not a capacity that you need to build internally. And so we can come in and help you out. Yeah. And with that concludes the third in our series of webinars this week. Again, I'm Brian Scouten. Feel free to reach out via email. I would appreciate any contacts, and hopefully we can help you with your migration strategy. Again, thank you for participating in our webinar.